Hello, everybody, and welcome to our LocalStack community meetup. I'm Brian Rinaldi. I lead developer relations here at LocalStack, and I'm really excited to have you all here. This is like our biggest meetup of the year. We have, I feel like, I don't even know how many speakers we have. We have like 8, 9 speakers. We've got a full a full bunch of really great sessions coming up for you. You're going to learn all about everything that came out in LocalStack 4. We've been so busy here at LocalStack. In November was kind of a crazy month. We announced our Series A funding. We were at reInvent as sponsors. And we released LocalStack 4. So we've been really, really busy, and we're super excited to share all of that with you. So first off, I'm going to introduce all of our speakers and tell you how everybody. I guess we can switch slides here. Yeah, so I'll give you the agenda, tell you about our speakers. So we're going to do obviously the intro and welcome, which is what we're doing right here. We're going to have Valdemar talking about Road to LocalStack 4.0. We're going to talk about what's new in LocalStack. So Harsh is going to give you a rundown of everything that's new, and then we're going to go into some tech demos. They're going to dig deeper in some of the bigger features that we announced in LocalStack 4, including Bedrock, Kubernetes, Event Studio, and more. Then we're going to talk about some of the community and resources, because one of the biggest things about LocalStack, as you know, because you're here for this community meetup, is that we've got a really, really great community. And then finally, we're going to do some Q&A, and I'll tell you how to submit your questions and things in just a bit. We can jump to the next slide. Okay, so we did the intro and I already welcomed you. So let's meet the speakers. Obviously, you've met me already, but we're going to have everybody jump on screen here. All right, look at that. See, I told you there's a lot of people. It's a Christmas party here, and Simon is the only one properly dressed for it. So we're going to go around the room, and we're going to introduce everybody from left to right, top to bottom. So we're going to start with Harsh. You're going to tell us your name, your role here at LocalStack, and then you're going to tell us what's your favorite Christmas treat. So, like, I just got back from a tour of Germany and Netherlands and stuff, and everybody was just loaded with Glühwein as one example of a Christmas treat that you might particularly love. So, we're going to start with you, Harsh.
Sure thing. So, hi, folks. I'm Harsh, and as some of the veterans of the LocalStack meetup group might know, I have been hosting these meetups for quite a while right now, maybe over 2 years, if my memory serves me right. So, at LocalStack, I work with Brian and Anka, and as you might have seen me, I have been hosting a lot of these meetups. You might see me at different conferences, building a lot of LocalStack demos, and just reaching out to you over community Slack. So, just so excited to be here to be talking about LocalStack 4.0 and talking about my favorite Christmas pastime. I guess this is the first time I'm actually going out on a vacation on Christmas. So I will be going out on hiking and trekking. And I'm also expecting to do some adventure sports. I'm not sure what is really going to come out of that, but just hoping everything is going to be all right.
Guys, Valdemar.
So great to be here. Yeah, my name is Waldemar, CTO here at LocalStack. As Brian mentioned, I think it's been a very, very busy year for us all at LocalStack. We just returned from AWS reInvent a couple of weeks ago. It was like super successful, extremely engaging. So yeah, looking forward to the quiet time of the year and also to the session that we're going to have here today. My favorite holiday treat is probably gingerbread. It's kind of really the only time of the year where I actually eat this. So yeah, I love it. Can't get enough of it.
I did see lots of gingerbread as well on that trip through Germany. Silvio.
Yeah, hello. I'm Silvio. I'm a developer in the core team, so developing the core product of LocalStack. Maybe you've seen me in a previous meetup where I talked about our Elasticache and MemoryDB provider. This time I'll talk about exciting new Bedrock provider. And in regards to Christmas treats, I think nothing beats cookies. So I would say cookies. Yeah.
Awesome. Anka.
Hi, everyone. I'm Anka. You've probably seen me around as well. I do developer advocacy at LocalStack. I'm based in San Francisco. And for Christmas, any food that I don't have to cook myself is very exciting for me. But I guess I do miss the Glühwein, which is mulled wine for anybody outside the German-speaking area is watching. Yeah.
Awesome. Lucas.
Hey there, awesome to be here. So my name's Lucas. I've been and still am a software engineer at LocalStack. Joined, I think, like 2 years ago, something like that. Working mostly on the web application and all the features around that. And my favorite Christmas treat would also be cookies. There are lots of different sorts. And in Austria, we bake lots of trays of different ones. So I gotta choose that.
All right. Max.
Hi, so I'm Max. I'm also a software engineer like Silvio. I'm also working with the core. And my favorite Christmas treat to be I'm a real big fan of advent calendars, which is, I think, also very common to the Austrian German region, where we have, like, for each day, a door which we can open, and there's usually such a chocolate which you can get. But this year, my mother made me one which has like healthy protein treats inside. So I'm really happy that I got this one. So that's what I enjoy for until Christmas. But at Christmas, I will probably eat a lot of unhealthy stuff. So.
Yeah. Yeah, I think a healthy protein advent calendar is not approved by Santa.
Then I will get Krampus's visit probably.
It's Simon.
Hi all, I'm Simon. I've been working at LocalStack for a couple of years. The previous one of these community meetups I did was about the exciting topic of networking. Today's topic is going to be equally thrilling. My favorite Christmas pastime, mostly because you can only get them at Christmas, is mince pies.
I don't even know what a mince pie is.
You don't know what a mince pie is? Well,
no.
It's confusingly not mince. It's not beef mince. It's dried vegetables and fruit peel.
Oh, okay. Yeah. All right. Excellent. Yeah. I didn't even get to say my favorite is also cookies, but it used to be like when I grew up, half my family's Italian, so my aunt would make this giant pile of all these different like cookies, this Italian recipes of cookies, and it was I literally haven't had that since I was a kid, but I still miss it. All right. Well, thanks everybody. I'm going to say goodbye for the moment to you all, and then we're going to continue on with our little bit of introduction here, one by one. Everybody's being removed. Okay, so we love the kind of audience participation in this. We're going to be presenting you a lot of different things, and we'd love for you to ask your questions. So you can ask those at Slido. You just go to slido.com, put in that code, or use that QR code as well. Please ask your questions as we go along. After each of the kind of demos, we'll have a moment to answer any questions that might come up about that specific demo. Also, at the very, very end, we will open it up to everybody for like overall questions or anything like that. So please get your questions in. We'll be monitoring that as we go along. All right, so that's it for my intro. You don't have to hear me kind of blabber on anymore. Let's get to the meat of the presentation here. And to do that, we're going to welcome our co-founder and CTO, Waldemar, who's going to tell you about the road to LocalStack 4.0.
Awesome. Thanks so much, Brian. Yeah, I also want to sort of keep it relatively short because we want to really focus on the live demos later in the presentation. So I'm sort of, my job here is to just briefly give you like a bit of a historical overview of how we arrived at 4.0, where we came from the open source, over the last couple of years, and then also some highlights of what we've achieved throughout the year. So our journey thus far has been quite phenomenal. So those of you who have been following our progress for the last couple of years, we started in the open source as an open source project around 2016, 2017 timeframe, and ever since, I guess, have seen phenomenal traction and also contributions from the community. So big shout out to everybody who's been sort of a user, a contributor to this effort, and really giving us this constant feedback and making sure that LocalStack is really a high fidelity development platform that you can use to run your AWS applications locally. So one thing is worth mentioning here, besides some of the impressive numbers that we've seen, GitHub stars and Docker pulls, I think we're scratching on the 300 million which is pretty substantial. But also like the speed of innovation is really accelerating. So especially in the last couple of years, anything from version 1.0 onwards, and whenever sort of we started building out a team, we can see that there's a very strong innovation engine that's happening at LocalStack, and it's great to see like all the things that are coming out on an ongoing basis, which we're also sharing with you in these community meetups. So this is just a sort of brief overview of some of the key milestones, especially with the major releases we've had in the last couple of years. One thing that we mentioned in the intro was that we just returned from AWS reInvent. It was the second year that we had a booth there, and it's extremely, on the one hand side, it's a bit it's very exhausting, but also extremely energizing to have all these conversations at the expo floor, talking to users, customers, the AWS community more broadly. So we're really excited to be part of it and really bring this product to the broader audience. So when we think about or look at some of the key highlights of the year, and it's really hard to summarize this in a single slide. LocalStack as a company, as a team, has so many threads of activity, so much going on, so much innovation. But there's a few things we can briefly point out here of achievements that we put out in the product throughout the year. So we added support for entirely new services, including things like event bridge pipes, DMS, Bedrock, which we'll actually see in the presentation later today, MemoryDB, and a bunch of others. So we are tracking 100+ AWS services at this point that we support in this local development environment. So I think quite impressive progress there. There's been various improvements in Lambda, ECS, like all our compute services, really giving you this local environment that you can debug your applications with, have these quick feedback cycles, and really make sure that you have a joyful and efficient developer experience with your cloud applications. We did a bunch of rewrites of some services, including step functions, API gateway, and others, where we really saw these are highly used services, and we wanted to optimize some of the internal implementations. And in fact, also had some interesting sort of interactions and collaborations with the AWS product teams, so specifically for step functions, where we put out a blog post together with them as well. And there's just a number of enhancements in persistence and cloud pods, which is a feature that some of you may already be using or have heard about, which really allows you to persist the state of a container. We put a lot of innovation and new features in that as well. First-class Kubernetes support is something that Simon will share more details around, and also live demo. We're having ongoing enhancements around CloudFormation. So it's really one of the key services that's pretty central for any infrastructure as code integrations like CDK, for example. And we also launched a first version of Snowflake emulator, which you may have seen a couple of months ago, and that's currently in preview. And we're working with some early adopters on this new product. This is kind of just to summarize a few highlights in the core emulator, but equally on our cloud platform, we're adding more and more features. We add a lot of user interfaces for example, the IAM policy stream and also chaos engineering, which are two main features that we highlight in our web app. So go check it out if you haven't seen it yet. We've launched ephemeral instances, which is a new feature that's under preview right now that allows you to spin up local instances in a VM that's hosted by our cloud. So really enabling application previews that are running in an ephemeral instance for you to easily preview changes in your application. And also several resource browser views in the web app, and generally a lot of enhancements in the developer experience and onboarding UX. Again, too many to count. This is just some of the highlights. What you can see on the right-hand side here is also the team at the booth at reInvent. So again, we had a lot of very exciting conversations with the broader community, and couldn't be more excited to working with you all, getting the feedback on an ongoing basis. And we have some ongoing developer experience initiatives, some of which will be also shown in today's demos. Event Studio, Max will present that shortly. And also we'll continue to innovate around Lambda debugging and IDE integrations to really give you a localized version that you can sort of set your breakpoints on, debug, and iterate very quickly on your logic. The third point, last point here on the DevX initiatives is AWS Replicated. It's just something that we're now sort of rebuilding and building out as an early preview. It really enables things like hybrid scenarios to bridge the gap between your local environment and the remote environment, and allowing you to really zoom in a certain part of your application, do the development there, and then sort of connect to your remote cloud instances as well and resources. So stay tuned. There's lots more coming out over the course of next year. We're super excited. And yeah, with that, I'm going to hand over to the team doing the intros for the demos.
Sounds good. Thanks, Voldemar, for presenting a high-level overview of whatever has been happening in LocalStack. And I'm just so excited to be presenting about what's new in LocalStack. But I just kind of saw like a pretty interesting question on our Slido session that was talking about what were the first services that actually got into LocalStack. It's pretty much an interesting question, and maybe I can share like a bit of a history around this. And I'm not sure like if Voldemar exactly remembers that. So let me just put it on the screen right now. Uh, Voldemar, do you happen to remember this?
This is I don't know where you dug this up, but this looks like ancient. So it looks like some of the first coverage files and like the early make file.
Yeah.
Yeah, I mean it's very very long time ago if you just look at the history of what we've achieved in the meantime. But I think some of the early services like API Gateway, a Lambda, a DynamoDB, I think like the serverless stack was really where everything started. And again, today we're at 100 plus services. So just imagine the journey we've been on.
Yeah, I also kind of imagine the number of different ports that people used to had to integrate to. I still see like a lot of the older blog posts that talk about some ancient version of LocalStack saying like, you have got this port for Kinesis, this port for DynamoDB, this port for Lambda, and it's just a mess to kind of work with. So it is kind of a testament to how far we have came from that initial commit back in 2016, where you can just use LocalStack as a drop-in replacement with whatever integration you're working with. And I guess like this is the commitment that we have been building on so far. So stay tuned. And maybe let's jump back to what's new in LocalStack 4.0, and I can just give a quick rundown of whatever has happened. So yeah, let's move over to the next slide and talk about some of the new features. So some of these features that I will be talking about, we have more expansive demos that will be further drilling down into, but I'm just giving a pretty high level overview about what has came about. So the first thing, the flagship feature of the LocalStack 4.0 has been our new Bedrock emulator. Like this is a question that a lot of people were asking us, like, do you support Bedrock? Can we run local LLM models? Can we just happen to integrate and test against a Bedrock mock or an emulator? And we just so happened to hear from the community directly, and we decided to build the support for this. So the new Bedrock emulator is now available in LocalStack, which already supports like the invoke and converse endpoints. And you can basically use this new emulator to run and invoke LLMs locally. For this particular purpose, we are using public Ollama models. So we are thankful for the great community that Ollama has built and the support that they provide to the end users to be able to run LLMs. And we just so happen to be excited about all of the latest advancements in the generative AI ecosystem. And we have been further drilling down into how we can support our community out there so that more and more users can feel confident about building AI applications today with the help of LocalStack. We are also working on integrating more advanced features, but this is something that Silvio will be further discussing about because he's the lead engineer on the Bedrock side of things. But as you might expect, like batch processing, batch streaming, integration with other AWS services, and in the future, even support for multimodal inputs or rack pipelines would be soon coming about. So I'll let Silvio talk a bit more about this while I jump to the next slide in this section. We also have got these new updated emulators. As you might have guessed, the support for some of these new providers actually came about in the previous minor versions, but we decided to make them the default with LocalStack 4.0. So we have got the new emulator for Event Bridge, a new emulator for API Gateway. All of these is basically promising greater parity with AWS, better interoperability with other AWS services as well, and just a more fine-grained support that is definitely supported by our continuous like feedback and improvement that is going on about in our AWS services. So definitely give them a try, and you will definitely see a lot of improvements in performance, in the parity, and how they exactly work out with your AWS workflows. Uh, Moving on to the next, and this is something that I'm personally really excited about, which is the support for the new Event Studio. This is a very initial preview version, and this is available to like our pro customers. But this particular feature basically enables a lot of these event-driven workflows and how you basically develop, test, and debug them today. So with Event Studio, you can technically observe and understand your event flow. You can replay these events. You can get a feedback on like these AWS service misconfigurations that are very hard to test on the real AWS cloud. You can also identify missing IAM permissions, and you can enhance your event context. Our primary purpose of building a product like Event Studio is to open up the AWS as a black box where you can directly peek inside it and you can get to see how the different services talk to each other. Because let's be honest, like AWS is such a giant system with different services talking with each other, which basically adds to the inherent complexity. And with LocalStack as a local cloud emulator, we can look into that complexity and we can really make that simple for you. So again, Max would be doing a full-on demo around this, so I'll let him do the whole talking, but it's just something that should really get you excited about. We also have like support for LocalStack SDKs right now. So some of the folks that have been working quite deeply with LocalStack would know like we have support for a lot of these internal developer endpoints for a lot of different services like SNS, SQS, SES, and more of them. So we decided that it would be much better to kind of wrap them around in an object-oriented interface and offer them as SDKs that people can directly integrate with their tests or with their application code. So with LocalStack SDKs, you can basically build on top of these internal developer endpoints, and you can use them for a lot of different purposes. Right now, we have support for our SDK in Python and Java. But in the coming future, we would definitely be listening to the community around the support for other language SDKs, and we are definitely going to work on that. It also integrates with our proprietary features such as CloudPods and Chaos API. And down in the future, we are also going to invest more upon the interoperability with some testing frameworks like test containers or JUnit or PyTest, so that you can easily use these SDKs in different environments. Finally, we have got several of these new web app features that Lucas would also be talking about. But just to give a pretty high-level overview, we have got a couple of preview features, which is the revamped IAM policy stream, which allows you to basically generate a stream of IAM policies based on every single AWS API call that you make. We also have got a new stack overview page that is simply going to blow your mind, but I'll let Lucas show you that. And we have some minor features like the Event Bridge Pipes resource browser and some new save and load features for CloudPods directly on the web app. With that said, I would also like to bring the highlight on some of the important notes. So some of the users who are already using like LocalStack on CI, like they must be using the older LocalStack CI keys that we are on the path to deprecate. So we would definitely recommend you to migrate to the new CI auth token. And this particular exercise is to just enhance the whole security and the whole assignment process. So we have like our complete documentation available, which will guide you towards migrating to the CI auth token. And in the following year, we will make a concentrated focus on deprecating the older CI and the LocalStack API keys. Apart from that, the non-prefixed environment variables are now deprecated. So every time you are starting LocalStack container with some of these like non-prefixed environment variables, the container is going to show a deprecation message. And it is now encouraged to basically add this particular variable prefix that will make things simpler for you. Finally, users also now need to set up their AWS credential in their init hook script. So you explicitly need to set up the AWS access key ID or the AWS secret access key or the AWS default region, because the default credentials that we used to pass in these init hooks are no longer set automatically. We have an even longer migration guide and some of the other deprecated stuff, but I'll just guide you to this particular blog, which documents all of these together. So take a look onto this and make sure that you migrate to all of the recent changes that has happened in LocalStack 4.0 so that you can have a seamless development and test mode going on with LocalStack itself. I guess with that said, we can move on and hand it over to the next speaker, who is going to be Silvio. And yeah, I guess Brian is definitely going to do the introduction.
Yeah,
so
I guess I'm doing the
yeah?
introduction. Yeah,
Yes,
so
definitely.
thanks, Harsh. That was awesome. I think it's just shows how much stuff has been released. It's really crazy. But I am super excited to actually have Silvio come and talk, because when we were at reInvent, I remember somebody came up and they were like, they jokingly said, "Oh, do you have support for Bedrock?" And I'm like, "Yes." And they're like, they kind of laughed, and I'm like, "No, I'm serious. And it's also emulated." And they're like, "What?" They did not believe me. So I think it's super exciting. We had a lot of people very excited about it. So Silvio, I'm going to let you tell everybody how it works.
Yeah. Hello. So first of all, like some people were very excited about Bedrock and already know what Bedrock is, but first I'll just give a quick introduction what Bedrock even does and what it is. So it's like quite a new service. I think probably a bit more than 1 year old, for foundation models. So what are foundation models? It's basically a new way to describe all these kind of generative AI models that popped up over the last 1 or 2 years, like the large language models and some diffusion models for generating images and also videos. So yeah, this is something that Amazon obviously also wanted to like take a part in, not leave everything to OpenAI and so on. And yeah, this is what they introduced. And the big benefit of Bedrock, as opposed to like the other ones, is like it is part of the Amazon ecosystem. So you can do quite advanced stuff, like what's also quite the rage right now is like retrieval augmented generation. So it only takes content that you have and that you have stored in your own Amazon AWS infrastructure and like fine tune your models for your needs, and also some agentic features to like interact with your infrastructure. So that's all very nice. And like, as we know, all these foundation model applications need quite a lot of computing power. And then the question arises, why do I need that locally? It's a bit like useless, no? But actually, it's not useless. It's quite important. As we can see, there are some benefits to it. You can predict more what's going to happen, because you can see in this Reddit posts, or like also this tweet from like well-known people in the AWS community, is some weird stuff happens around Bedrock, like suddenly you just lose your credits. You can use Bedrock for some reason anymore, maybe because there was on your application there was like a lot of traffic, and then they just stopped that. And sometimes also maybe it can happen that you incur like super huge costs and didn't want to do that, and so on. And also in some cases, you maybe for experimental stuff you don't want to like share some data immediately with Amazon, but also want to have it locally at first. So yeah, this is why we decided to also have a local emulator, obviously also because of the huge community need for that. And yeah, so I'll switch to the demo now and show what our Bedrock emulator is capable of right now. So I've already started LocalStack in the background to save some time, and we also introduced environment variable to immediately start up Bedrock with starting up LocalStack, so that we don't have to wait for the loading of the model and so on, because that can also take quite some time. So when we look at the Docker containers, we can also see that we have like an Llama container running already. Yeah. So what I first want to show you is like Bedrock supports a lot of models already. So if we take a look here, that's like a very, very long list of models. What we restricted ourselves in this first iteration is like text models. So every model which handles and generates text, like large language models. And we also emulate it all with like one model which is defined on startup of LocalStack. So if you give like a model ID Titan or Mistral, it will all use the same thing. You can select yourself which model this needs to be. Right now, the default is the small LM2 model from Hugging Face. But yeah, what we can do, what Harsh already talked about, is like just simply do some converse API call, like ask a Bedrock what is LocalStack, and it will take some time, but hopefully not too long. Usually it's a bit quicker, but with the streaming and so on, it might take some more time. Yeah, it's like on my machine, it's like around, I don't know, 3-4 seconds to do that, like specific call. But yeah, as we can see, running it locally does introduce some kind of hallucinations because obviously the models are not as good. So I don't think that we're an online web hosting platform, but yeah, that's like not the most important part when using this local emulation. Obviously, if you want to have the good results, you will have it in production. So doing it, so using Bedrock locally mainly means that you can try out the features that are on top of the LLMs and still have some kind of LLM support, but to have it interacting well with your other Amazon AWS infrastructure. So one of the things that we have already added is batch inference, which you can try out. So what happens there is you can have a JSON line file. So have a file with JSON inputs for your model, and then create a batch job which goes through all these inputs and generates an output. One benefit here again is you can try it out with a smaller set. When I implemented this feature and tried it out on the big Bedrock, you need at least 100 lines for it to actually like accept the input. But locally, we can just remove that restriction, and you can try it out quickly and iterate quickly and fix your app if something doesn't work. So yeah, what you need to do is to have an input and an output bucket and put like a JSON line file here. And then you can also like copy this file into the bucket, and then you just start your model invocation job. As you can see, like the invocation job is started, and then you can check what's happening. Right now, it's still in progress. Hopefully, it will not take super long. But as we've noticed before, in the stream, it can take a bit longer than what I've tried out before. So we'll maybe have to wait a bit here. Still in progress. I've also have the LocalStack logs on the side, and I think we're almost done. So still in progress. Should be done now. So if we check the invocation jobs again, you can see that it's completed, and then in the end we can just copy the output. So for this we will need to know the ID of the job, which is auto-generated on AWS and also on LocalStack, and then take the file which will have the same name but with .out attached to it. Forgot to add the other path. And then we can look at the output. So looking at it, first I wanted to know where Walder is, but yeah, that's not how text models work. They don't know where Walder is. They will always only say that they're text models, and they can't do that. Then I wanted to know how can I remove Bedrock, but in Minecraft. And having looked at it quickly, this seems like a wrong answer. The right answer is obviously some piston glitch. And finding elves at the North Pole, we can see that the AI model also doesn't know where elves are. But that's something for the future. Maybe in the future they will know that. So we can go back to the slides now so that I can talk about what will come up in the future, because this is like not the end of it. Right now we've seen there's the core support for just running the Converse API, also the invoke model to sending like raw requests, and this batch processing, which is like a smaller advanced feature above this whole API. But in the future, like we're already planning to add more things. Recently, they've added also in AWS async invocation support, for example, which will obviously also add in LocalStack. And as we can see in the console, in the AWS console, there's quite some new things coming up. And also, especially, there's this section of the builder tools, which will also focus a lot on around knowledge bases, which is basically their implementation for resource augmented generation and also the agentic features. And this is something we'll look on in the future, because this is like the real value that you get when you use Bedrock instead of other providers. You can have these advanced features on top of these foundation models and have them interact with your AWS infrastructure. So that's that. And I'm open to questions now, if there are some.
Yeah, there are apparently a couple. But though, first of all, I wanted to point out that Harsh kind of mentioned in our little private chat here that it wasn't entirely hallucinating about LocalStack, because it was doing localstack.com, which I guess at some point was a hosting company, not localstack.cloud. So that was, I guess a reasonable error. That being said, I do hope you plan to support better Minecraft related prompts. This is definitely a feature we need in the upcoming release of LocalStack, because I need my Minecraft questions answered in LocalStack for sure. Okay, so we are getting these questions up on the banner. Just wait. There we go. Okay, so there's a skeleton of a deployed model running locally. Is everything running on the client machine where LocalStack is? You're just emulating the API?
So basically, like we said before, we are using Ollama, which we can run in Docker as well. So we can use any kind of foundation model, large language model, even bigger ones. The one I chose is specifically meant for running in weaker machines and like edge environments. But theoretically, you could also just run Llama 70 billion parameters as well, but I don't think that will go well, especially because in Docker we don't have the GPU support for all the platforms. But yeah, it's like a proper real large language model, which is just running locally on your machine, and you can interact with it however you want. Then you probably also would get better Minecraft answers if you like use a better model there. So we kind of already support it.
There you go. Perfect. All right. Next question is support. If you support the bigger models, I guess not much would change, as the real model part is just a tiny basic model. I guess this kind of similar question to what was being asked before. Like you specifically chose default like a tiny model, but you could choose whatever model you want.
Yeah, you can just set in. If you look into our documentation, we have an environment variable where you can set that. At first, I was thinking of using like a slightly bigger model than that, which produced better results, but we have to think about like all the users that we have, and using a too big model then will lead to maybe not so good results for every machine, and maybe also like just not work because you kind of need the RAM for that. So I chose as a default a fairly small model so that you can get going, and if you need something better, you can always choose a different model, and you can choose any model that's available for Ollama, which is on the Ollama website. You can check it out there.
So if you have a beefier machine, you can choose a better model, is what you're saying.
For example, I tried out Mistral with 7 billion parameters, which worked quite well as well, but not on every machine, so didn't choose that one.
That makes sense. Okay. So is the benefit of Bedrock support to validate that your application is correctly invoking the APIs and the code will work end to end once you deploy to AWS? So, I mean, I guess, yes, more or less. Yeah.
Yeah, that's like one of the main benefits that you can put Bedrock into your maybe already existing stack. You want to get in on the hype and have some AI functionality in your app, and then you can test it out locally, iterate on that, and then when you deploy it to production, you will know that it works.
Yeah.
But of course, there's also like some other. Yeah.
Go ahead.
There's also some other features that you might use, like the resource augmented generation, which will increase this benefit as soon as we will implement that.
Okay. And like as you mentioned, I think one of the things that came up is Bedrock. You can run out of credits really easily, start racking up charges. So this is an easy way to like test that you've done everything correctly while doing it locally without racking up a huge bill. So, okay, we got, I think, one more question coming up. Okay, what GPU are you running?
So the interesting thing, it was quite fast. So you would be thinking that I'm using a GPU here, but I'm using a Mac, and on Mac there is no GPU virtualization for Docker. So I'm restricted to using CPU models. So everything you've seen just ran on CPU, and it was still, even while sharing my screen and so on, and video and all these things, still work quite fast. Obviously, way faster when I'm not doing that. But yeah, it all works as well. But in the future, we'll also look into, because Docker has GPU support for Linux, so we'll look into supporting that as well. If you have an even bigger need for like a bigger model and so on.
Very exciting. I think, like I said, I talked to a lot of people who are super excited about this. Obviously, you can see lots of questions. So people, I think, definitely want to mess with this. So very cool stuff. Thanks for building that. And thanks for presenting. All right. So on to our next speaker. So Simon is going to talk to us about unified Kubernetes support. Go ahead, Simon.
Hi. Yeah, thanks for introducing me. I'm afraid I've come down with one of your traditional Christmas colds, so forgive me if my voice is not the clearest. But I'm going to be talking about some of the work we've been doing improving our support for Kubernetes in LocalStack. So I'm going to assume a bit of Kubernetes knowledge just vaguely, but maybe to kind of summarize for those who are less familiar. Kubernetes is a way of running containers like Docker containers, but also orchestrating them. So choosing where they run, choosing how they connect to each other. It's very powerful, it's very flexible. It's also got quite a steep learning curve. So one of the reasons we're focusing on this is that we have, through talking to customers, particularly some of our larger customers, they have mentioned a move away from Docker, both as a deployment target and as a local development kind of way of running LocalStack or local technologies. So this is motivated for a couple of reasons. So number one, Kubernetes is often kind of like what's running in production anyway. So if you can emulate your local environment through Kubernetes, you can leverage LocalStack to emulate some of the AWS components that you may be using as well. But also there's slightly more less technical reasons. So recently Docker Desktop changed the way their licensing structure worked. And so we've noticed some companies are choosing alternative containerization systems for local development as well. So we think Kubernetes is becoming more and more important for the reasons I've outlined, and I think it's only going to get more important. So specifically, what's new in LocalStack 4.0 or over the last year or so, we've been kind of gradually making these changes. Previously, we assumed Docker was the environment that LocalStack was running in. We, for example, use Docker to run technologies that we leverage, like Lambda functions or some database technologies. We ask users to mount their Docker socket into the container. Generally, Docker also has the historical problem that it's running as root or super user on your computer, so it's got access to do anything. So there's a bit of a security issue with Docker running locally as well. But this assumption that Docker is being used for everything is not holding. It is not going to be sufficient going forwards. As I said, larger companies are moving away from Docker in general, moving towards other technologies. So Kubernetes is a really hot topic at the moment. What's new again is specifically some of those technologies where we've assumed Docker is running. We've now had to write specific handling for those situations where, say, Docker is not available or LocalStack is running within a Kubernetes cluster. Part of the changes also are we're focusing on some of the more advanced services. So some of LocalStack will run, or some services in LocalStack will run on Kubernetes just fine. Some of the more simpler services like SNS or SQS, not simple in the kind of service sense, but simple in do they rely on Docker technologies or not? Or a kind of more complex networking, for example, is another place. Or even they're fundamentally based on containers. So ECS, for example, is fundamentally based on containers. The big change for this release itself is that we've now standardized our offering for Kubernetes. So I mentioned before that this is primarily driven by some of the larger customers, either larger companies or larger users of LocalStack. So we're initially setting the licensing fairly high bar. So enterprise customers, our enterprise offering will unlock the Kubernetes support, again targeting some of the companies that have bigger production workloads, or they're bigger organizations in general that are looking at Kubernetes. So if I move on now to what I'm going to demonstrate for you, the demo is going to be LocalStack running in a Kubernetes cluster. So LocalStack is running on Kubernetes. We're also emulating a few services that leverage containers, in this case, Lambda. Please forgive me if you don't necessarily know what the logos are. I certainly haven't memorized all of the AWS logos, but the architecture you can see, we have a Lambda function, and that's going to communicate to a MySQL database. So this MySQL database is running as a Kubernetes pod. The Lambda function will be running as a Kubernetes pod, and LocalStack itself is going to be running as a Kubernetes pod. So let's move over to the demo then, and hopefully this will work. Let's see. So hopefully my font size is big enough. I've replicated the architecture again on the right-hand side. We can see the Lambda function, the MySQL database, and LocalStack running as pods. So I'm going to show kind of multiple sort of pages. This might get a bit complex, but in the top panel here, we see this is a program that gives you a kind of interactive view of a Kubernetes cluster. So you can see what's running in your cluster. And currently, as you can see, there's nothing on this, so it's empty. I'm showing what's called the pods. You can think of a pod as effectively a container. It's not quite one-to-one, but it's pretty similar. And what's going to happen is Kubernetes is going to manage the life cycle of these pods, so starting them, deleting them, so on and so forth. On the bottom, we'll eventually see some LocalStack logs when that's been deployed into the cluster. So what I'm going to start off doing is We have a Helm chart. So Helm is like a package manager for Kubernetes. We have a Helm chart that can deploy LocalStack. It deploys a pod for the actual container itself, and it deploys a few other resources that I won't go into now, but I recommend checking out the Helm chart. It's really useful for getting started. I have a lot of these commands as make targets, so I don't have to make lots of mistakes while demoing this, but I'm going to start off by deploying LocalStack. And what this does is it runs that Helm chart. I can quickly show you what that looks like. So using Helm, we're going to add the Helm repository. Helm is, it's like a package manager again, so you can add different repositories for different sources. So I'm going to add the repository, and then I'm going to install Kubernetes, install LocalStack into the Kubernetes cluster. So here I'm doing, these lines just say run the LocalStack chart out of the LocalStack repository, call it LocalStack. This word gets repeated a lot in this demo. I'm going to take some configuration values from a kind of customization file, almost like a local file that contains some specifics. And then I'm going to add my auth token because it needs authentication. So if I have a look at the values, this is specific to our Helm chart, but it's some general purpose configuration that you will need. So for Kubernetes, using the Helm chart specifically, we have these two settings at the top here. And I tried to kind of highlight which is important for Kubernetes. The first one is a setting for our Lambda functions. So Lambda functions in kind of Docker mode, they run in their own separate Docker container, whether they're an image Lambda or a zip file Lambda. This is a specific setting for the Lambda Kubernetes executor. And then down here in this extra nvars block, we have more traditional LocalStack configuration, so with environment variables. And in this case, we set the container runtime to Kubernetes. So this configures LocalStack to say anytime you want to create a container, create a Kubernetes pod instead. And then down here, we have some other configuration that's mostly for demo purposes, things like debug logs, changing the length, the life cycle of the probes, and so on and so forth. And this tells us when LocalStack is ready. The rest of this, the file is not important for the purposes of this demo. So now we have LocalStack running. In the bottom, we have the LocalStack logs. We see it says ready. And I can move over to a terminal and say AWS local get caller identity. So this proves that I can connect to the LocalStack pod running in my LocalStack cluster, running in my Kubernetes cluster. For those who do know Kubernetes and know about local development with Kubernetes, I have this third tab up here, which is running a port forward from the Kubernetes pod to my local machine. So that's how I'm getting AWS local to work, because it connects to localhost by default. Okay, so we have LocalStack. Now what do we do? Well, we need to deploy that application. So I mentioned the application is, that one. The application is, so now we have LocalStack running as a pod. Now we need this, it's very hard to see on the screen, I think, but there's a VPC that contains the Lambda function and the RDS database, MySQL in this case. So I've created this application for demo purposes using Terraform. You can use any way to get your application into LocalStack. Any of our local wrapper tools like CDK local, Terraform local, they will work. This demo happens to be in Terraform. And I can run these commands. So the first make target just does a reset. So Terraform stores its kind of state of the infrastructure locally in files. I'm just clearing that out because we've created a fresh LocalStack instance. I don't want any confusion with what I might have deployed before. And then I'm using our tflocal command to apply the Terraform stack. This takes a little while, and it's actually, interestingly, not LocalStack that takes the time. It's Terraform has got some configuration. It says, if I'm deploying this resource, don't bother checking it every 2 seconds because it's going to take a while. Come back and wait. Come back and check every 10 seconds and do that 10 times or something like that. So it is going to take a while, but not for LocalStack reasons. I can show you the Terraform configuration. It's fairly straightforward. So the three main things I'm deploying are the VPC, a database, an RDS database is running MySQL, and a Lambda function. So the Lambda function gets its database configuration through Terraform variables, in particular, the database instance address. So this is what's returned by LocalStack. to say this is the host name you need to connect to, and then the DB instance port, which is the port that we're going to be connecting to as well. I can also show you the Lambda function itself. The specifics of this Lambda function don't really matter, but what I'm doing, this is in Python, is I'm creating a MySQL connection to the database. I am creating a temporary table, basically doing some SQL work, but this is just to demonstrate connectivity between the two pods. I'm inserting some data, and then I'm going to query for all of the data. So if we go back into the LocalStack logs, we can see some things are being deployed. We are executing some SQL commands. We are now creating the function. So this is configuring LocalStack to run a Lambda function in a pod. And we have apply complete. So this application has now been deployed onto LocalStack. So let's give it a go. So how can we test this? Well, I've shown you that the Lambda function calls in, connects to the SQL database. I have a make command to invoke the Lambda function. I've also made this print what it does. So in SQL terms, it creates this temporary table, it inserts some data into the table, and it selects star from the table. And then the Lambda command itself is just invoke the function. It doesn't take any arguments, and we get back the results. What I think is quite nice about this is that Kubernetes is designed to abstract over infrastructure. So you can have one kind of central view over all of your application code running as containers, regardless of what host they're running on. In this example, I'm just running a single one node minikube cluster, but these pods could be running on separate machines in separate sections of a data center. They could be they'll be taking advantage of all of the Kubernetes configuration and power, specifically to do with networking. So that's the end of my demo. What's next for this project? I would say we haven't got full coverage, so LocalStack is not completely supported on Kubernetes. There are some services, some of the more complex services that we haven't emulated or we haven't added specific Kubernetes support for. I would like to kind of complete the story. So some of the services that we're missing are, for example, EKS, which is a bit of a weird one if you imagine that. So EKS is Amazon's Kubernetes service. So emulating Kubernetes on Kubernetes, it could be quite fun to investigate. And similarly to do with Kubernetes, we've made a push for Kubernetes, but there's also other alternative container runtimes, things like Podman and Container.io that aren't 100% up to parity with Docker, and we'd like to push into that support further as well. Okay,
that sounds great.
And
I know we have gotten a lot of questions about that lately, about alternatives, including things like Podman and stuff like that. So, and you have the inception idea of like running, emulating Kubernetes on Kubernetes. Yeah, and then spawning Kubernetes within that. You could just keep going, right? Eventually.
Yeah. Yep.
You would just kill your machine.
And then, you run LocalStack on an EKS cluster that's emulated by LocalStack, and then you run that on all the way down.
This is going to have to be your next demo at the next meetup. Like, how many times can you? How deep can you go? All right. So, okay, I think we did have a couple questions from the audience. How are services like EMR and Glue run with LocalStack and Kubernetes? Are they also run as separate pods?
Forgive me, I'm not too familiar with our emulation of those. I think they're run. I don't think they're run as containers. I would say if we run a service with containers in the background, I've shown you Lambda and MySQL, for example. I know that those two services we haven't looked at for specific Kubernetes support. So if they do use Docker, I'd say they're on our to-do list. If you're interested in specific Kubernetes support for services, please get in touch and let us know. I'm really keen to know which services we should focus on.
Excellent. Okay. And then I think we had one more question. Is there a blueprint for setting LocalStack on EKS? Last time we tried, it was not easy.
Okay, I'd be interested in understanding what wasn't easy. So please reach out to us and we can work through the issues you had. On EKS specifically, I don't think there's any particular issues. Our Helm chart is really useful. I'd recommend trying that. There are some, I mentioned in my kind of overrides file that there are some tweaks I made. I think we might want to change our defaults because for local emulation, they work fine. but when I've tried EKS in the past, the memory and CPU requests and limits are a bit tight. So on EKS, I'd definitely consider bumping those up, but I'd recommend our Helm chart.
Awesome. That's great. And I think just as a reminder for folks watching, I mean, if you do want to reach out, we do have our community Slack, which is a great way to kind of reach the team. We're all on there, and we monitor it all the time. So you can find that on our website. So just slack.localstack.cloud. Great place to check out, to ask us questions, answer, or get requests like this, or talk to Simon. So thanks, Simon. That was great.
Thank you very much. Bye all.
Okay, so we've got another demo coming up. This one's super exciting as well because Event Studio, while it's in early kind of preview state right now, it's really, really cool. So I'm going to let Max show it off. Take it away, Max.
Hi, thank you. Yes, so let me introduce our new offering, Event Studio. And as Harsh already mentioned, it's a bit about kind of opening what we call the black box that AWS often is, because you cannot peek inside. You don't necessarily know what data services send between each other. And this is what we try to do with Event Studio, make it easier. And so let's maybe phrase a bit the problem so we know what we are talking about and why is this relevant. So the big problem, as I mentioned, is inter-service communication. And what do we mean with that? For example, if you take this sample application, which I will be showing you later in a demo, is you have a DynamoDB table, then you have a Lambda, which is added to this DynamoDB table, data stream via event source mapping. It gets new writes into the table, enriches it, and then puts it into queue, maybe for another Lambda to pick it up. We don't care so much about that. We only care about these three services. And this is, if you work with it, if you have experience, relatively easy to implement on the surface level, but there are multiple pitfalls, and it often has to do with how is the data changed? How is the data format that you receive from the DynamoDB table? Maybe your Lambda fails because you have not anticipated everything correctly. How do you enrich it with the Lambda? Do you put it in the SKS queue? Maybe you make some errors there. Maybe there are some edge cases which are hard to run all the way through the pipeline. So there are a lot of problems where you would rely on knowing what data is exchanged between the services, which, I mean, you can set up some samples and get around it via the hard way, but Event Studio makes this quite easy and quite straightforward to peek into that. So let me show you how we do that. So we basically, for now, have these 4 steps, how we make it way easier for you to understand how data flows and what data flows between these services. And basically put you into the driver's seat that you can, with the data, go through each step, how it changes, what it is. Yeah. So the first part would be surfacing it. What events are there? What data kind of goes through the system? Surfacing all the different steps. The second part is connected. So if it's just random events, you would not necessarily know, okay, what service talked to what, where am I focusing right now? So the second part is connected into a nice graph, so you can easily identify the part which you're interested, maybe the part where the error is, and focus on that subpart. Again, I will show you in the demo how this looks. Step 3 is bringing you to details. This is actually what you're mostly interested in, but you have to get there stepwise. And this is showing you the data, showing you the content, showing you the metadata, basically giving you all the necessary information for you to figure out what you need to change, what is wrong. And the fourth part, which is very exciting, is now if you say, okay, I adapt my Lambda, and then I have to think of, okay, what data do I have to put into the DynamoDB table that the Lambda is invoked in exactly the right data format? But you don't have to do that anymore with Event Studio. You can right away, for specific steps in your enrichment process, just replay this state. And this will then automatically invoke all the services afterwards. So you can, at any state of the system, replay it, which makes it way easier to iterate on your systems. For now, we have mainly 4 screens for these 4 parts. First, we surface it via a list where you have all the events. Then we connect it via a graph. In this graph, you can also see the details for any particular data you are interested in, and then you can replay it. I will afterwards talk a bit what the future outlook is, how we want to change that. But now let's go into the demo. So I set up the same sample app as we had in the beginning. So we have a DynamoDB table. This is connected to a Lambda via event source mapping via DynamoDB streams. And this then just writes into an SQS. So let me switch to my screen. So first, you can right away, right now, install the extension via the web app. Just go to your running instance or to extensions and install it. And then I already started a LocalStack instance with the extension installed. And now let me deploy also deployed the stack because takes a bit, but now let's put some sample data into the DynamoDB table to see what goes on there. So I have a make target for that. This just simply adds 3 users into our table, which stores the users. And if you pay attention to the left side of the screen, you can see that there are events coming into our system. And this is what happens in real-time. Events are, as we capture them in the backend, they are in real time pushed to the front end, and you can see them here. And these are now all the events that are captured by our system. This is the first step. The second step would be connecting them. Okay, so how does this look? So let's, for example, say, okay, I'm interested in the first event. What's going on here? Then I would click on that. And then we see this in a connected graph. To be frank, this graph is now not as sophisticated because we have a simple demo app, but this is in theory and in practice how it would show up. So what does this show you? We have several steps. We see a graph node, and this shows you what service is involved and what is the operational step. And you can then, as the data traverses through your system, we capture each transformation step or each service invocation, we capture this event. So let's say the next one would be, okay, it was written into the DynamoDB table. Now the next step is that it is this DynamoDB stream kind of picks it up and forwards it. Then it would invoke the event source mapping the Lambda, and this then would run the Lambda, and the Lambda itself writes something into the SQS. So let's now look into the next step, the details. I told you that's the most important part because now we basically captured our output and we saw, okay, this is not the data we put in. There is something wrong. I mean, I made a kind of an error. Let's figure out how we have to update our Lambda that in our SQS is the data we actually put into the stream and we enriched. So let's go to the Lambda. Okay, we see what was the payload that was invoked with the Lambda. This is exactly the data as a JSON Lambda gets invoked by a payload. We also see, for example, metadata, when was it invoked, what was the account, what was the Lambda function name, but we are now mostly interested in this. And okay, I made a bit of an easy mistake, but maybe this is the beginning in the problem when you come up with a stack, how you also approach it. So I did not know what would the data look like that the Lambda receives from the DynamoDB table. And I was a bit too lazy to read the documentation, so I just put it here. And now we'll use Event Studio to figure out what data structure Lambda receives from DynamoDB stream. So this shows me that we have an event name insert. Okay, I'm only interested in insert, already got that. Then we have the new image. Okay, this is apparently the new data which I'm interested in. And we have it via keys for each column and then the type of string or number and the data. Okay. Here I'm a bit lazy, so I already have that pre-coded. So let's say now, okay, now we figured out this is what we want our enrichment Lambda to do. It reads the existing data, where it just adds in timestamp and then just says, if it's in a particular company, we say it's defaultly subscribed to user. So let's now update our stack with the new Lambda that correctly reads the data. Let's give it a few seconds. Yes, my laptop really doesn't like me streaming videos, then it's a bit slower. Okay. Yes, so it synthesized it, it deployed it. Yes, so now the Lambda should be updated. And what can we do now? We can again put stuff into our DynamoDB table, have it traverse all the steps, but we actually are only interested in this particular data set. So what we can do, we can actually use the replay feature. So you see here, you have the replay button. Again, I will probably show that in a future session where how you can also use that to manipulate data, because you can change, for example, to what target, to what consumer you want to replay. You can change the payload, but for now, let's just keep it. And let's just replay as it is. Give it a few seconds. Okay, that looks good. And now, I actually wanted to show you that they're quite a bit different, that you can see that something happens. But if you see, you would have seen that there are new events coming in. So maybe let's do it again. So if we replay it, you see, it's updating it. And it's only updating it from this side to the right. So there, nothing happens because it's only replaying it from here. And let's see if actually our invocation data changed. And ta-da! It actually is the data which we expected and for what we corrected our enricher. So this is how you can easily use Event Studio for figuring out where your errors are. But this is not everything. So you can also use Event Studio for capturing IAM permission issues. You can use it for capturing invocation errors and errors down the line where you would not even reach to this stage that you can replay the Lambda and you can invoke the SQS, but it's just an error because you made a mistake. And what is also very exciting, we added some kind of logic where we think we infer how you could have maybe wanted to configure your stack. And then we highlight you with warnings if you have not configured it in a way how we think the stack should be configured. This is still in the early phases because it needs some kind of inference from our side, but it is very helpful for more complex services, for example, like EventBridge, where you would have rules and targets. And for example, if you forget to attach a target to a rule, we will warn you. Attention, maybe you wanted to connect the target and here's no target. But overall, this is the current state of EventBridge, Event Studio, and it is very exciting for like speeding up the process of figuring out where is my error, why is the error happening, and how I can solve it, and then replay it to quickly iterate on that. Yes, that's actually it. Brian, I think you're muted.
Oh, yes, I was. Sorry. My dogs were barking and I didn't want y'all to hear them. So like, right. Okay. So, mistakes happen. But one of the things that's super exciting to me about this is, everybody thinks local stack. It's just like, okay, I can do everything I did on AWS, but I can do it on my local machine. But where I think it gets really exciting and things like this show it is you can do things because we're running locally. We can do things that you can't do on AWS. And give you insights you wouldn't get on AWS. So like, it just kind of opens up a whole new set of capabilities that we just really, they wouldn't be able to do on AWS. So I think that's super exciting. And this is really cool. I really love where it's going, but we do have a couple questions from the audience. What services does Event Studio support?
Yes, so currently we support EventBridge, we support DynamoDB table, we support Lambda, we support SQS, and we support SNS and S3. but we are constantly adding new services. And we also support an API gateway in a basic level. Yeah.
Okay, awesome. And then one more question I think there was, which is, how does it compare to something like X-Ray?
Yes. X-Ray is, I would say, if you're familiar with AWS, X-Ray would be something which you immediately think, this is similar to X-Ray. I would say this is like X-Ray on steroids and like with completely new features. So it, in the sense, it gives you the X-Ray capabilities without needing to configure anything, but it gives you so much more. It gives you these replay features. It gives you that you can look into these events. You don't necessarily only see what events are kind of evoked, so the trace, but you also see the content. So yeah, it is a bit similar to X-Ray, and we also partly build in the backend on X-Ray for these tracing features, but it is so much more, which, like you said, you would not be able to do on AWS.
Excellent. And then actually, we got one more question that came in as we were speaking here. Is it available on the web app? How do we get started?
Yes, I showed that in the beginning of the demo, so you can quickly install it via an extension. You just go on the web app, you go to either your instance under extensions or just to the main extension. Then you see Event Studio as an extension. I think it's the first one to the left. You install it, and that's it. You don't have to configure anything. You don't have to. If you're interested in IAM policy streamings, you have to enable IAM soft mode, but that's it. No other configurations like required for X-Ray. Just regularly deploy your stuff, and for each supported service, we will capture the events. We will show you them in a list. We will show them in the graph.
Excellent. And this is another one that, just a reminder to folks, this is in an early preview, so like we would love your feedback on our Slack, and you can reach Max or any of us there.
Yes.
And give us feedback, because we are still developing this feature, and we'd love to know kind of where you'd like to see it go. So please join the Slack and communicate with us. So thank you, Max. That was excellent.
Thank you.
All right. So speaking of the web app, we were just talking about the web app, so we're going to go ahead and dig into that a little bit more here with Lucas, who's going to talk about new features in the web app.
Most definitely. Thanks for introducing me. Thanks for having me. It's a pleasure. I have the honor of speaking on behalf of the whole SaaS team about the new exciting web app features. So without further ado, let's jump right in. Today I'll be talking about two specific features that are very exciting. One of those is the stack overview, which should help you discover resources in your stack. And the second feature will be the UX improvements we've made for the IAM policy stream, where you can verify policies before going live. Just some screenshots from the get-go. I'll show this off in a demo in a second. Stack overview, again, aims to answer the question like which resources are in my stack. Previously, if you deployed an application on LocalStack, you didn't have a nice graphical overview of what's actually deployed. In this case, we've built Stack Overview. It's currently available in the preview state with 18 resources being supported. And it also supports showing multi-regions or multi-account setups. So on the screenshot, you can see a list of, a couple of resources deployed on my instance. For IAM policy stream, we're building on top of the existing functionality. So pre-version 4, we already had a setup which allowed you to inspect missing IAM policies. And with 4.0, we released an improvement in terms of the UI, making it easier to find missing policies in your stack, and also trying to just get your information more quickly, so speeding up your dev flow. For the demo, I'll be taking the notes-taking app. It's a sample we have on GitHub with a very basic architecture put here. So yeah, why don't we jump right in, and I'll show you around how to use the Stack Overview feature and the IAM policy stream for this application. So what you can see here is my screen. And basically what I did is I cloned this repo here. It's a sample nodes app, DynamoDB, Lambda, API Gateway on our LocalStack samples org. And thing is, We will do everything live, so wish me best of luck so everything works. I will start LocalStack as the first step because it's currently not running on my machine. And after that is ready, I will run the command to deploy everything of this application. So in the meantime, what I can do is I can talk a bit about the architecture diagram and what the idea of this note-taking application is. The note-taking application allows you to store notes in DynamoDB. It's very simple. It's a UI hosted on a CloudFront distribution, and the code for that is stored on an S3 bucket, and it then makes requests through API gateway to a bunch of lambdas that interact with DynamoDB at the end. If we navigate to our web application, we can see that the local stack is already running and the stack overview is getting populated. So I have believed that it's already ready, but it's not yet ready completely. So we have to wait a bit more. For the stack overview, what we can see is, as I mentioned before, a list of supported resources. So in the case of our demo application, we can see that there's one REST API and API gateway. We can see that there are currently 3 lambdas. There will be more in the end. It also is creating some roles apparently. And also there's a DynamoDB table. So why is this useful, right? Well, as I said previously, before this feature, we actually had no idea what was in your local stack instance. You had a container running on a machine, you deployed something, you don't have any idea of what is happening. You could go to the resource browser and kind of like navigate to each service individually, like checking out the Lambda functions. But then you kind of have to switch back and check out the resources in API gateway. On the overview page, however, that is all consolidated and allows you to just get an easy view on your application and also understand how it is set up on your stack. So if I check out the deployment again, I can see that it is finished. And I can now go to the UI. So very simple. It displays a page which reads your notes. It has a nice light and dark mode toggle here. And it allows you to create a new node and enter some text. Now, spoiler alert, the application has a bug. It's missing an ARM policy. I gotta be honest, from the get-go. It's an error I introduced for the demo. But why did I do this? So as I mentioned before, the application reads and writes to DynamoDB, right? And if you want to make sure that that is the case in production, I have to be very sure that those policies are in place. And for that, we built the IAM policy stream. Because if the Lambda is trying to write to DynamoDB, it will miss the policy and nothing will work. So on the UI, we have the option to enforce IAM policies or not enforce them. The difference is that if we enforce IAM policies, the call is actually going to fail. So to demonstrate this, let me add a note here. So I click on create. It redirects to the main page, but my note isn't there. Weird, it should be there, right? So switching back to the IAM policy stream, I can quickly spot that here there is a red sign, right? Clicking on it, I see that the put item operation on DynamoDB was denied. Why is that? Well, because we're missing this policy here on the Lambda function. So what I can quickly do, just to unblock this quickly, is I can copy the policy, then I can go to the role that the node creation Lambda has. I can go to the role policies and create an inline policy. Let's call this put item from Lambda and just insert the thing I copied from the IAM policy stream. If I click submit, the IAM role policies of this Lambda should now read and include the put item from Lambda policy. And if everything went smoothly, everything works for the demo, I can now actually create a node. Let's try that again, and maybe also for the demo purpose, do it side by side. Let's click create. Awesome. We saw a demo. We saw a node here. We also see that here in the list, the put item operation, which was previously erroring and denied, is now a success. And this way I can be sure that the deployment will succeed on real AWS. So this was for unblocking the demo, but since I mentioned this is a CDK deployment, right? I now know that the Lambda is missing the action to put items into DynamoDB, and I can quickly add that to this Lambda role definition here. And if I would now redo the deployment, it would work from the get-go. So yeah, that was my demo. With that said, I think we can switch back to the slides or the Q&A session, and I'm happy to answer any questions you might have.
Thank you, Lucas. Again, this I think goes back to stuff that you can't easily do inside of AWS, but also as a reminder that if you aren't using the web app, I don't know why. I use it all. I rely on it all the time just to kind of even do simple things like, oh, I just want to invoke a Lambda, or I want to see what's inside my DynamoDB table. So yeah, it's just really a incredibly useful tool when you're running LocalStack. We do have one question, two questions. They're just coming in fast. So is Stack Overview working also with pods?
Interesting question. I am delighted to answer yes, that is the case. So the Stack Overview feature we've built for the locally running instance, but it also is supported for pods. So if you want to create a pod from your LocalStack instance and have a graphical overview of what is actually inside the pod, we do offer that. It's setting an env, and then you're good to go.
Yeah. Okay. Great. And then next question is IAM policy stream on the desktop app?
Excellent question. I'm afraid that's currently not the case. But we have been definitely talking about adding new web app features to the desktop application. So if there is hunger from the community, then we definitely want to add it.
Awesome. Okay, great. Thanks so much, Lucas. That was a great presentation. We really appreciate it. So we are now going to jump to talking about you all, talking about the community and resources with Anka. I'm going to turn it over to Anka since I know we're running low on time. So go ahead, take it away.
Anka, you seem to be muted.
Oh no, I'm sorry. I was just making
sorry
sure
to be the bringer
that,
of the bad news.
yeah, there's no coffee grinding in the background. Okay, so if you made it this far, I'm gonna keep this brief. This section is about you. Thank you for watching. In the next slide, we can see a collage that the community was good again this year. And these pictures highlight the growth of the community. I made these in parallel. I made this collage in parallel with the one from last year. And these are not pictures taken from a better angle. This is just the growth of our events and people showing up to watching our demos and talk about LocalStack. And in the next slide, we have some numbers to back that up. There is clear community growth. Our community Slack has grown by almost 2,000 people. The newsletter subscriber number has increased by quite a lot. LinkedIn has almost tripled, I guess, the numbers of followers. We're going to exclude X for now because, yeah, they make it kind of hard to get that information. On GitHub, we are at 545 contributors. And to put that into perspective, I just checked, Elasticsearch has a little bit under 2,000, so we're doing very well. And the past year, since V3, we have gained almost 7,000 new stars on GitHub, and our meetup community is now at 801 members. It's growing all the time. Yeah, and in the next slide, I think, yes, we're going to be talking about the newsletter briefly. We had to create a separate section in the newsletter because all of you are starting to create your own content. And honestly, it's really hard to pick 3 pieces every month. We want to foster and nurture this sort of activity, and you being self-sufficient and creating content for the community. That's why if you want to participate, you can write to us. We can feature you in the newsletter. And in terms of events, I want to do like a little recap for the past year from V3 to V4. In the next slide, we can see that we are meeting you where you are, and this is across the entire globe. We've been at Config Management Camp, Docker Dev Tools Day, PyCon Africa, All Things Open and reInvent in the US. We've done online events. We're participating in a lot of AWS, Python, Java, DevOps meetups. And of course, I'm not going to give you the statistics of how much content we created. It's a lot. We're going to keep those numbers for internal use, I guess. And you may have noticed that our engineers are doing demos in our virtual community meetup, and that is no coincidence. We want you to get the best and direct highlights from the people who develop the services, and this is becoming a place where the creators are meeting the users, and that's a very good environment to be in. Obviously, if you want to demo your use case and if you want to participate as a presenter in our meetups, please feel free to reach out. And in terms of resources for next year, what can you expect? Well, the org LocalStack samples is also growing. We have about 90 repositories of samples. The majority are linked to the developer hub, which will also see some improvements. We will like to do some more live hackathons. And since I moved previously in last year, there was nobody in North America, and now we have 2 advocates on the East and the West Coast. So we'll be seeing more activity in North America. We want to improve our documentation because we know it's very good, but sometimes it can be hard to navigate. So we will try to make that a better experience for you and try to put more effort into making the community more self-sufficient, because maybe we won't be around all the time or we won't be available all the time. You need to find help where you require that. Maybe we'll sprinkle in some more AI because that's the trend, and we want to offload some of the repetitive tasks and streamline you finding answers to your questions. And of course, we're going to be touching the moon because that's where we're going with this growth rate. So I'll see you in 2025, and I guess this is my last slide, and I can hand over to Harsh.
Thank you, Anka, for giving a quick rundown of everything that has happened with the community in the past year. So I'm going to be talking about the last aspect of this whole session, which is going to be like, what's next? So if you're someone who is already using LocalStack or someone who is just getting started with LocalStack and just saw all of the stuff that we have released out with 4.0, the one thing that you will be wondering is, what are our next goals? How do we further want to define and redefine cloud development and testing for you? So just to give a very quick aspect of where we see ourselves right now, LocalStack, like the whole idea behind LocalStack was to create like a local cloud emulator that can allow you to develop and test your AWS cloud applications. But as you might have already seen right now, we are building a very strong developer experience layer on top of LocalStack that allows you to do a lot of things that are not really possible to do on the real cloud. For example, we have got features like Event Studio, IAM policy stream. We have got stuff like advanced debugging features with the new Lambda debug mode. We're going to have like a session on that coming soon. And also stuff like Lambda hot reloading. So all of these features basically allows us to create a really sticky experience with LocalStack that just enhances your whole cloud development experience. Apart from that, we are also investing quite a lot onto our SaaS product, which is the LocalStack web application. So giving you these resource browser that allows you to replicate an experience similar to the AWS Management Console. Some other tools out there that allows you to manage your local resources and do some advanced development and debugging. We are all making that possible right now with the web application. With the new release of SDKs, you can now also use LocalStack to like write your own test suites. So you can integrate that with any of the popular testing libraries like test containers or JUnit or PyTest. And you can really test your AWS applications like on your local machine itself, which will further give you like much more maturity and much more confidence about deploying your cloud apps on AWS. And finally, this is just a sneak peek about what is coming soon. We are making it possible for you to actually delve into some hybrid scenarios. So if you're working on something that we call as a replicator mechanism, that would allow you to replicate your real AWS resources back to your local machine. This is a feature that we have been discussing with a small set of customers right now, but keep an eye on like the community and on the releases that we have been doing. And this would be something that would really make it exciting and really make it possible for you to use LocalStack in some hybrid development scenarios. To just talk about some of the things that would be coming about next. Obviously, like some of these things are pretty obvious. Like we are going to have improved parity with AWS. We're going to invest more on expanding the SDK support, as I have already mentioned. Simon mentioned that we are going to have like a further more optimized Kubernetes support. Right now, it is only limited to Lambda, ECS, RDS, DocumentDB, and some of the others. But we would be expanding that further to really make it possible for you to run LocalStack on Kubernetes clusters and also in enterprise environments where compliance, security, and cost saving is the paramount stuff that we need to have. We're also trying to invest on making the switch between LocalStack and AWS easier. In our experience, we have noticed a lot of customers and even internally, we always set up like if local flags that basically allows us to switch between LocalStack and AWS. We are going to make sure that this isn't really the case in the coming releases, and you can easily switch between LocalStack and AWS depending on what exactly you're deploying. Some advanced dev and test tools, test data management with cloud pods, and as you might have already seen some of our news around the new Snowflake emulator, we are going all in with the whole multi-cloud tooling ecosystem. So the Snowflake emulator is already being developed right now. It is already gaining a bit of maturity, and we might be approaching the 1.0 release for our Snowflake emulator very soon. You can also keep an eye on the upcoming Azure emulator, maybe Q1, maybe Q2. We are not so sure about that, but just keep an eye. And this is definitely something that is going to rock the whole local cloud development ecosystem. And finally, from a SaaS perspective, we are going to invest in like more enhanced resource browsers. Right now, it is almost 50 services that we support resource browsers for, but this is obviously something that we are going to expand. And we are going to build an entirely new observability layer on top of the CI integrations. A sneak peek of that was already given at AWS reInvent, but we're definitely going ahead with productionizing this and making sure that we can make it available to all the general users. So all in all, what we are aiming for right now is to build LocalStack as a platform that covers all the stages of the software development life cycle. So up till now, the first impression that people used to get from LocalStack is that it's an individual developer tool. You get the core cloud emulator, you get the whole ISC and the dev tooling integration, you get some extensions and plugins to work around with this. But we are definitely expanding further right now. Now you can not just use LocalStack on your local dev machines, but also in your CI environments, where we have features like CI analytics, stack insights, detailed telemetry that allows wider teams to collaborate together when they are building their applications on LocalStack. Furthermore, with the release of ephemeral environments and cloud pods, you can really collaborate together. So we can basically facilitate inter-team collaborations or intra-team collaborations, and make sure that you can use LocalStack as a way of ensuring that all of your cloud app deployments are going to work fine. And not just that, you can also like share like some of the infrastructure stuff that you're working on with some other colleagues, so that they can really know what is basically being worked upon. And finally, for all of the team leads and for the management, we are continuously investing on our chaos engineering feature suite that basically allows you to inject some random chaos experiments into your local cloud infrastructure. And I guess like some of the upcoming priorities would be around how we can measure the development productivity with LocalStack, how we can really quantify that for you, and also how much LocalStack really save for you. Because the one thing that we have been hearing from everyone else out there is that LocalStack really allows us to like save a lot on the cloud cost, especially for the development and testing part. We are going to make sure that we can quantify and measure that for you, so that you can exactly know how LocalStack is going to fit in your business use case. With that said, I guess we are almost at an end. So let's bring Brian back into the stage. See if you have any questions.
We don't actually have any questions at this point.
Okay.
I know we went super long, so we're just gonna kind of do our goodbye. So I want to just thank you, Harsh, for helping to put this all together, as well as all the people who spoke. And in addition, everybody, like, just a reminder, there's a big team behind the scenes who didn't get up here and speak, who worked really, really hard on this release, and all facets of this release. So thanks to the entire team, but also thanks to the community, because honestly, we would obviously not be here if it wasn't for the community who had both using LocalStack, contributing to LocalStack, participating in the community. So thank you to you. Please follow up with us if you have any additional questions or you have any feedback on our Slack channel. Just going to put that reminder up one last time, and I'm going to say happy holidays, happy new year, see you in 2025. Bye.